Hello everyone. Today I'm going to talk about all types of loads in civil and structural engineering. It is including all potential and actual loads that we deal with in everyday design. In general, the loads are in three types. One is gravity loads, second environmental loads, and third are impact loads. Gravity loads that are very popular and we use in almost every design is dead load, or we call it superimposed loads, and live loads or imposed loads. Dead load is just type of the loads that permanently applied on the structure, like self-weight of the structure, self-weight of elements, and any type of, and also the finishes that applies in the structures. And the live load are just types of temporary loads or non-permanent loads or just some occasional loads like traffic loads or the human loads or furniture loads on the building. Here we have types of gravity loads that all in just direction of gravity. In inclined elements or straight elements, you see that it always applied in gravity direction. In columns, beams, floors, it should be partially loaded or just fully loaded, UDL, point load, or just any type of other gravity load. Units are kilonewton per meter for linear loads like self-weight of a beam, mainly steel beams that we consider in our design, or any type of like, let's say, a wall on a slab that we consider as line load or linear load, or should be just point load and also area load. You know that for self-weight effect, we just always do as pressure load on the floor. In this case, we just need just to multiple the density of the element on the floor to thickness of the element to make it kilonewton per square meter like area load. Second type of loads are environmental loads. These are very broad range of loads that we don't use in all design, but some are very popular. Environmental loads are earthquake load, wind load, snow load, rain load, or earth load or earth pressure, hydrostatic load, temperature, and settlement. The first one, or earthquake load or seismic load, is very popular in almost all designs, especially for importance level of 2 and more in structures. It is shear load. It's applied as shear load. That is a direct function of the mass of the structure. And K is function of the importance level of the structure, building ductility, and ground or acceleration parameters. W is just weight of the structure, and V is the base shear. You see here, that is earthquake is transferred from the ground to the structure, and this is the base shear from the earthquake coming to the structure, and it is distributed to the building from 0 in the base level, ground level, and the highest shear value is on the top level. It is still depending on the mass of the stories, and in this case we assume that all the stories have the same mass value, but if we have more or less values, we need to deal with the stiffness of the elevation levels and also the mass of the structure in each level. The second environmental load is wind. That is very popular in our design. It is wind comes in pressure, that is C fig dot V. V or V squared in general. C fig is the factors like dynamic, shape factor, earth, topography factor, shape factor, and all factor comes in this C fig. dynamic factor of all this, and V is wind speed that comes from the regional wind. That is parameter of the return period of the wind. And you see that we have compression, suction, suction, compression, suction, compression, and also we have drag force for wind. So in general case, it is external pressure, suction and compression, internal pressure, suction and compression, and drag force that is applied on the second direction or just in perpendicular to the main direction of the wind. Sometimes this drag force is very important and very critical. And this internal pressure especially is just very dependent on the porosity of the structure or the area or the opening of the structure, allowing wind to circulate inside the structure. Third one is rain and snow loads. It is generally considered as area load on the structure, and for rain especially, sometimes we go for ponding effect. This is the normal distribution of the load from rain or snow, and if we have ponding effect, we may have P delta effect as well, that is extra to the area load applied from the rain and structure. Sometimes it is very critical and it increases the deflection and it may cause the collapse of the structure. The other one is earth pressure or soil pressure, that is divided in two parts: active pressure and passive pressure. Active or attacking pressure, that we are going to design the structure for that, and passive pressure, that is helping the structure to withstand the active pressure. It is function of the density of the soil and also height of the soil, and pressure in each level is K active gamma soil density times H, and other side passive is Kp gamma soil and H2 or depth of the passive soil. It is very simplified shape, and just sometimes we may have just more complexity depending on the density, saturation level, water ground level, and also soil parameters and soil type. The other one is hydrostatic pressure, that is almost the same distribution of the soil, but in this case it is much more simpler. It is just function of the density of water and depth of water. It applies lateral load on the structure. This is just typical shape for, let's say, pool. That is this water pressure in lateral direction is gamma H. Gamma water H. H is depth and gamma W is water density. We have two notes here. If we have saturated soil or wet soil, in general, we will have soil pressure plus water pressure in the structure. Soil pressure is the same Ka gamma soil times H soil plus gamma water H water. If the water level is groundwater level is lower than the soil level or ground level, we just consider the level for soil and level for water at different levels, but the process and the principle is the same for load calculation. Also, one major risk in hydrostatic pressure is uplift pressure. When the water level or groundwater level is higher than the foundation, we will have, in addition to the pressure, in addition to the lateral pressure on the structure, let's say here, we have gamma H. Let's say if this is H depth of water from the foundation level, we have gamma H uplift pressure to the structure. In this case, we may need to have weight increased weight of the structure, increased weight of the foundation, or sometimes we're going to have screw piles to take the tension loads from uplift pressure. It is sometimes very critical, especially when the building is near the river or creeks and water area. That water level, we need to just drain the water, or if we can't, we need to design for uplift pressure. That is sometimes very critical. And also for gravity, soil has active and passive lateral pressure, but it has also gravity pressure as well. Same for water, soil. For gravity of soil times depth of soil is giving the pressure, gravity pressure on the area, and same for water. Gravity of water times depth of water gives the water pressure in gravity direction. We need to consider all these loads coming from water and soil. The other one is temperature load. Temperature load is not used in everyday design, but sometimes it is more critical, especially when the structure is under effect of temperature, let's say high temperature of the environment or just special temperature loading. For temperature, we have two different types of loadings. One is uniform temperature loading on top and bottom or all around the section. And the other one is just we have different temperature at top and bottom fibers or just extreme points of the section. Just let's assume that T1 is less than T2. In this case, we will have bending effect. And bottom layer will be in tension, top layer will be in compression. It is just very simplified shape here, and it is just function of the restraints on both ends. But in general, we say that for this type of temperature loading, we may have bending effect and tension compression in the section. It is very similar to bending effect. But for these things, when the temperature is uniform in the section, we will have just axial loading effect that is coming in just if T is, let's say, over 0, or it is just warming, it is heating, it is just, we will have increased length, or if it is just decreasing or freezing load, freezing temperature load, it should be just decrease of the section. It will be tension or compression of the element or axial effect. Another environmental load is settlement of the foundation. For settlement, we have in general two types of settlement: rotation and vertical, or let's say we will have sometimes horizontal settlement as well. For rotation settlement, applied M, or the reaction on the foundation, will be M equal to KR, K or stiffness in rotation times theta. Theta is the angle between the initial and the later position. And same for vertical or horizontal settlement. The R, or reaction on the structure, on the foundation, will be KV times delta L. Delta is the settlement in generally in millimeter, and K is function of the soil and all these structure types. So in this case, we can have reaction on the structure, that is type of loading on the structure. It may have, let's say, if A, B, C, in any of this, if we have any settlement in rotation or just vertical or on compression, we will have load in other elements. And the last part is impact loads. Impact load is just like car hit or impact. We can say these are mainly dynamic effects. Or second type is free falling object, like free falling rock on the structure or any mass on the structure, blast impact or explosion impact. And the last one is machinery impact, like vibration and rotation of the machine on the structure and its effect on the structure. For car hit or car impact, it is simple. In general, we have two levels of car impact. For small cars, we're going to have in half a meter from the ground, and for big cars or trucks, we have 1 meter from the ground that effect. For half a meter, that is a small car, we generally have 5 kilonewton, 1.5 or 5 kilonewton max, the point load effect applied on the structure, and it is just we're going to have in 1.5 meter spacing. And for 1 meter height effect for big trucks, we have about 30 kilonewton, 40 kilonewton, or sometimes if it is very critical structure, we're going to have 45 kilonewton acting on 1 meter height. And then we're going to have just a structure with load and impact points. So we will have shear effect and bending effect, and we're going to design the structure. And just remember, from the other videos, in this case, the restraint on the ground is very critical parameter, and we need to care about that one. And sometimes we need to have just some pile or just very strong foundation for this one to take the soil, to just avoid rupture of the soil due to very big loads. The other one is just free falling object, that is mass falling freely on a structure. It is type of kinetic energy balance when the object is falling and when it crashes to the structure, and some part of the energy just absorbed in the structure and some part is going to deform the object and structure. Kinetic energy is just 1 over 2 mv squared, and absorbed energy that will be residual and deformation will be balanced or equal to this kinetic energy. And this is just general, very simplified method. 1 over 2 mv squared will be K F delta L. F is the applied load on this contact point, and delta L will be the deformation in millimeter mainly, or even less. And K is depending on the material type, material of the object and material of the structure, and it is very broad, and we need to just have very detailed parameter considerations to find this K value. And as I said, F is the load acting on this surface or heat impact surface. The last one is machinery impact. We have vibration, rotation, or shaking effect of the equipment or machines on the structures like pumps, compressors. And in general, we have footing under the machines or structure under the machine. What doesn't matter, we will have same considerations. We will have in general 3 types of loading: torsion, live gravity load, and horizontal load. But to design these things, it is very simple start point that always we're going to have frequency of the structure and frequency of the machine to match, and between 0.5 to 1.5 of the frequency of the machines, we will have amplification effect. So it is better always to keep the frequency of the support structure, support foundation below 0.5 of the hertz of the machine, or over 1.5, the 1.5 times of the frequency of the structure, and I recommend to always stay on this side. And the other limit is always just critical and controlling to design this foundation and structure under the machine is just weight of the structure. That should be always 2 to 5 times of the machine weight. I suggest to have at least 3 times. Let's say if the machine is 1000 kilogram, our foundation or structure should be at least 3000 kilogram weight. That is very critical and safe design for to avoid amplification and resonance effect, and have safe design for machinery impact. And the last one is blast or explosion. That is part of wave propagation, and it's still the same with energy. We have wave impact, just is hitting the surface of the structure, and the formation of this one just collapses, causing collapse of the whole structure or part of the structure. This is very special case study of loading, and that is very it needs much more parameters to design. Hope you it is mm, a very brief summary of the loads in structural or civil engineering, and I tried to have just cover of every types of loading, but design is each design is just case sensitive, and we need to have special constitutions depending on the environment, load case, structure, country, area, environment condition, and anything else. Thanks for watching. See you later.